Okay, so in this video, we're going to take a look at graphing inequalities. Right, so this will help us. Our main goal here would be graphing systems of inequalities, but let's just take a look at how do we graph, for example, the inequality y less than x plus 2. So I know that this is a line. Right, has a slope of 1 and a y-intercept of 2, right? So graphing this 1, 2. So this point's on the graph, and then slope of 1, so up 1 over 1. Okay, so Okay, so it looks something like this. Now, one thing when graphing this, when it is an inequality that is less than x plus 2, the way we're going to graph it is we're going to use a dotted line, a dashed line, right? So what that means is that you can think of the graph itself as being like the border of the inequality. Right, so when we have an inequality, it's not simply going to be just that line, right? It's going to be the set of points, either if we think of that as a border above this line or below it, right? So, for example, right, so if I choose that y-intercept, right, the y-intercept is the point 0, 2, right, where x is 0, y is 2, right? So if we plug in those values, right, y is 2, x is 0 plus 2, we get the inequality 2 is less than 2, which is false. Okay, so what that means is, well, that point is not part of the inequality. It's the border where it kind of cuts the two sets that will be that one is the solution and the other one is not, right? So for example, let's choose one that is clearly below that line. Let's choose the point 0, 0. So if I choose the point 0, 0, we get 0. We get the inequality 0 less than 2. So this is true. So what that means is that this whole area, right, under the line is going to get shaded in, right? That's going to be part of the inequality, right? Not just the line itself, but all of the points below it, because all of the points below it will, in fact, give me a true statement, right? And notice here, right, just so we can check here, let's pick a point somewhere up here. Right? So if this was 2, let's say a point up here, let's choose the point 0, comma 4, right? That's above the line, right? Okay, and then let's see what we get here. Right, so we get 0, comma 4, right? So we plug in 0 for y, 4 plus 2, we get 0 less than 6, which again clearly is false. Okay, that's how we graph a linear inequality. Now let's take a look at how about graphing y greater than or equal to negative x squared plus 1. Okay. So in this case, we have a parabola, right, that crosses the y-axis at 1. Excuse me. Crosses the y-axis at 1, right, and it is opening downwards. Now, in this case, notice one difference, a couple differences here, right? We have greater than or equal to, right? So in this case, if we do choose this point, let's say 0, 1, what do we get? Y is 0, x is 1. So we get 1 squared, and then a negative, so we get 0 greater than or equal to 0. So as it turns out, this statement is in fact true. Okay. So that means that instead of a dashed line, we do have a solid line, right? Because now this border will be part of the solution. Okay. Okay, so that's represented by the solid line, right? So that tells me that that is part of the inequality. If it's dashed, it says that what it represents is that it's not, right? It gets really close to it, but it never actually is part of the solution. All right, so now, again, the question is, which part do I shade in, right? Do I shade in the part that is above the parabola or below it, right? So again, let's pick a point here clearly in the in one of those sets. So in this case, 0, 0. And we get 0 greater than or equal to 0 squared plus 1. And we get 0 greater than or equal to 1. So this is clearly false. All right. So what that tells me is that what gets shaded in is everything that is above the parabola, right? And including the parabola itself for this particular example. Okay, and then you can take this approach with any type of inequality, right? You graph it and then you choose a point that is clearly not on the curve itself. And then whether you get a true statement or a false statement from there, that is you either shade where that point is, everywhere on the part of the graph, on the side where that point is located, right? If it does give you a true statement, if it gives you a false statement, then you shade the opposite side. Okay.